Hello everybody, how are you doing? My name is Roman Pletka. I'm a senior research scientist at IBM Research. We have been doing some really exciting research work here at the IBM Research Lab in Zurich on ransomware detection for storage systems. And I'm very proud to present you what we have achieved and what we are releasing for the IBM FlashSystem products using the IBM FlashCoreModules. Here on this overview I'm showing you an IBM FlashSystem all-flash array in the middle. On the bottom we can see several FlashCoreModules where we added a new computational storage function that is capable of extracting feature information from every I/O operation that is being sent to the FlashCoreModules. This functionality is all built fully into hardware, such that there is no delay on host I/O operations. The FlashCore module then summarizes all this gathered information for each volume. It can actually extract feature vectors from them. The feature vectors are then collected by the feature aggregation module in the higher level stack every few seconds. The feature aggregation module combines them into a single feature vector per volume that can be used to run inference on it using a supervised machine learning model. The machine learning model that we deploy inside the Flash system is a model that we trained outside the Flash system, and we are using a large amount of different traces we collected on real systems here in our lab and at various locations in IBM worldwide. These traces are from different workload types and different file systems and setups, and also include traces from real ransomware samples that we were executing in an isolated environment. The models we train are all based on decision tree ensembles. In case the inference engine detects a ransomware behavior from the feature information, it will raise an alert, sent to the storage insights automatically. Next, I would like to show you a real demo where we run real ransomware in a VM that is being executed on top of a KVM hypervisor in a host attached to the Flash system. Okay, this is my Flash system GUI, and on this particular Flash system I've already provisioned a few volumes. You can see them here, and these volumes, they are associated to hosts. I have two hosts on this system. The host 1, ZAG07, is the one that we use for this demo, and the vdisk4 ransomware detection demo is the one that is going to be used for this particular test run. It is a 1 terabyte volume, and now let's switch to the host where we will run the VM in our KVM environment. We can see the storage that has been provisioned here. It appears here as a mapper empath HH, and it has several NTFS partitions. These NTFS partitions are the actual Windows installation that I have prepared, and this Windows installation, I'm running this in a virtual machine. Let's going to show that here. So it's the last here in the list, so it's already running. We see it, and yeah, it's quite low CPU. It's just running fine. If we switch to the GUI of this VM, we can see that I have put a lot of data files already. It has HTML files, text files, PDF files, and a lot more. And those files are going to be attacked by ransomware samples. Let's look at one of these files. So this text file is actually some Python code that is being used. And there's another file, for example, this PowerPoint presentation that is here. Yeah, let's have a quick look at it. Yeah. Interesting. So these files are now going to be attacked by our ransomware. I have this ransomware sample ready here on my desktop, but before I'm going to really execute it, I would like to show you another GUI. And this GUI is essentially the data that we extract from the inference engine. So in this upper graph here, it's the prediction graph, it shows a value between 0 and 1. So when it is at 0, it didn't detect the ransomware and everything is just okay. But if the value goes up to 1, then the system is detecting a ransomware activity. And on the lower graph here, we have the confidence of the prediction that we did when it is a ransomware. Here on the next graph, we have also the inference time, so how long it actually takes to run inference for 1,000 volumes. And we can see it's less than 10 milliseconds, and that is pretty fast. Now let's go back to our VM. Okay, that's here. And we go to this ransomware file that we have, and we are just gonna execute it. Okay, select it and we run it. Here we go. So the ransomware is running. We see it that the CPU consumption is going up on the VM, and switching back to the VM, we already see that there is a ransomware notice, a warning file. Let's gonna have a quick look at what it's in there. And oh, here is all the information to get back your data. So the Bitcoin address where you have to pay Bitcoins and so on. But that's not what we want to do here, right? You're not going to pay Bitcoins. Here are some artifacts because these files are being encrypted and renamed. The editor already has some issues with handling those files. Let's just close it. Yeah, close this as well. Okay. Yeah, and we see that it started encrypting all these files. So these files have now an extension called .locked. And if we open the file that we were previously looking at, the editor already has an issue with opening it. And yeah, that's what it is. All the data has been encrypted. It's no longer readable anymore, unfortunately. At this point, let's quickly have a look what is still ongoing here. There is heavy disk activity going on. So the ransomware is reading data and encrypting it and writing it back to disk. So let's go and switch now to the inference result that I was showing you before. And indeed, we see that it already detected the ransomware very quickly. So the signal went up from 0 to 1. And we also see below that the confidence went up for this particular detection. And if we go down and look on how long this inference took, it's just the same, right? Irrespective whether there is ransomware or not, it's just taking less than 10 milliseconds to run any inference for the 1,000 volumes. Now, this flash system is also attached to Storage Insights. To see that, we have to go to the notifications. Okay, that's kind of the notification email that has been triggered. So we go to Alerts, Actions, View Alerts. And here we see the anomaly workload event that had been triggered. Everything has been detected as we wanted to have it. And I think let's go and switch back now to the VM. It's of no use anymore. So I just want to shut it down now. Shut down the VM. And once the VM is turned off, we are going to try to restore from an existing snapshot. So yeah, okay, the VM is down. And we can go into our FlashSystem GUI. We look for the snapshot that we had initially created on this particular volume. Local snapshots. And we select that particular snapshot. We do a restore on it. We have to select the correct subset of volumes. Here it is. So that's for vdisk 4 exactly. Restore. And we also have to type the name of that volume to be sure that we really want to restore this particular snapshot to this volume. And let's go. Okay, oh, that was pretty fast. Okay, the volume is back again, and it's still attached to the same host, of course, and looks fine from the GUI here. So let's switch to our host and let's start this VM again. The VM is starting now. We start the virt viewer to get the GUI of the VM. Yeah, there's some CPU activity already, and it takes some time until the virt viewer comes up. Here it pops up. Okay, let's gonna go full screen and log into this VM, and let's check whether the data that had been encrypted has been correctly restored. So we are back in the VM, opening this PC. The data is located in our documents folder. Let's gonna open this one, data. Yeah, this one here. And here we have the files. Well, they don't have the not locked extension anymore, and if we open it, yeah, okay, we can even open it with the other editor, notepad. Here we go. Okay, and that's the source code that we were looking at before. So everything looks fine. And let's quickly have a look at the PowerPoint presentation that we initially looked at. Here it is. Okay, we open it. And also, yeah, this PowerPoint presentation has been correctly restored, as all the other files. Thanks for watching. If you are interested in knowing more, please head to our website www.ibm.com/FlashSystem or reach out to your business partner who will be happy to show you more. Thank you very much and have a nice day.